Okay, so what do you get in the kit? You get, first of all, the Carnival motor assembly. So you've got the motor down here, and then you have the nozzle. There's a propeller inside here. And in this particular one, we're going to be possibly connecting it to lights. So we're using an electrical quick disconnect, which connects in there from the very thick submersible cable. When we run the lights, we would normally have a transformer that would sit here, and we run the cable into there, and another cable goes into the motor. We don't have the lights here yet, but the customer may be putting lights in at a later date, which is why we've got it set up for the lights. The pump motor may come like this with the quick disconnect, or it may be just a heat shrink join. But essentially that just runs back to shore, and then you have your control box, which your electrician fits out, and that's got motor protection and timers and different switches to make sure that everything is well protected from a motor point of view. Okay, so in this instance where you've got the electrical quick disconnects, you've got this dielectric grease, a silicon compound. So you cut that off and fill this up with that, and then you simply push that in. All the goop will come out to the sides, and then you just tighten that. You only need to do it hand tight. You don't use any tools on this. Basically, once it's in there, it's already considered watertight. This is just keeping it in place, and the goop that's gone in there as well acts as a secondary protection to make sure that no water gets in there. And that's it. So it makes it easy to remove the unit when it's out in the water. If for whatever reason you need to take the motor out and bring it in ashore, you don't have to drag the cable in with you. The other way of doing this is simply you won't have this box, and you'll just have the wire coming up and out, and it'll just have a heat shrink join, in which case the electrical connection isn't used. So sometimes they're set up with either configuration. When this is out in the water, this is where the point where the water gets sucked in all the way around. So this is a point that you need to clean. If this gets stuck with algae, leaves, debris, it's going to choke the amount of water that gets allowed to go through, and it won't pass through what it needs. And the motor actually needs a good flow of water going through, because the motors run hot, and that moving water that's passing through and up through the motor on the outside of the motor helps keep the motor cool and prevent it from aging prematurely, and making sure that all the internals are running at a correct pressure. So this is what you need to clean from time to time when you paddle out in your little kayak or whatever you do, and just make sure that all the openings around there are clean and free of obstruction. You'd also then put your hand in the down in the centre of the unit and inspect down there, which is where the propeller is, and if there's any debris in there, you pull it out. And if you can't get to that, then there's just simply 4 screws around the outside. You can pull that off and then get in there and lift out the rubbish that's pulled in there. Another thing that you need to do from a maintenance point of view, these motors are not oil filled, so you don't actually need to do any servicing of the motors themselves. The only thing you do need to do is make sure that this metal outer casing gets cleaned every now and then. Depending on your pond or your dam, that could be every month, or it could be every 6 months. It depends on how much gunk is in your dam and how much growth sits on this. And the reason why you want to just wipe that down and keep it clean is that growth will become a sticky biofilm, and over time, if that is allowed to build up kind of like scale on a kettle almost, but with sort of slimy stuff as well, what happens is that layer acts as a thermal blanket, and it makes the internals of the motor hotter than what they should be, which again prematurely damages the motor, or you don't get anywhere near as long a life out of a motor if you don't actually give it a clean every now and then. So definitely give it a clean. The cables that are used on aerolator equipment, it's all submersible rated cable. You can't just use any old electrical cable, because that's not going to be safe, and it's not going to be designed to go in the water. So the cable thickness may vary depending on the size of the motor, but the cable that they're supplied with is all submersible rated cable. And as with anything to do with electrical and water, you always make sure that you get a licensed electrician to do the installation electrically. All right, now the aerolator float is very well made. It's very strong, thick plastic type material, and on the inside is they inject it with liquid foam that expands like a polystyrene type foam, so it's not hollow. What that means is that in the unusual event that this gets punctured, which would be really unusual, because it's quite thick. But if that were to happen, it's not going to sink. It's just going to, the water will get in there, but it will still float in its own right because it's filled with foam. Now you'll see here that there's these little recesses here. That's where the motor assembly just drops in. There's no tools required to actually assemble the motor or to the float, or attach the motor to the float, or remove it from the float. So that's a very, very good thing when it comes time to install and maintain these things. It's just so easy to pull the motors in and out, and one just sits on either side. These other indents in the float are for the lighting system. So with the Carnival, you've got an optional lighting system, and what would happen then is that there would be a box that sits here with a transformer in it. The cable would run around, the lights would be mounted in these recesses. There's a larger recess there. That's for a metal plate that acts as a ballast or a stabiliser for the weight of the transformer to keep the float nice and square. The anchors that we use some of the old water treatment containers, lop the top off them, and then fill them up with some concrete, and we put in this wire so that it acts as a wire rope. It acts as a bit of a anchor point so that you can tie to it. You can also use Besser blocks, so the concrete building type blocks with the sort of cutouts or holes in the middle. If you do use those types of Besser blocks, what you're best to do is to cut a short section of hose, about 1/2 metre long, just garden hose, and thread your rope through that hose so that the rope goes through the whole of the Besser block. Because otherwise what will happen is that whether it's wire rope or polypropylene rope, that will rub up against the concrete and it will either wear down the block in the case of wire rope, or in the case of poly rope, it will break the rope over time because the Besser block's got a sharp surface. So we use wire rope for ours, and we bring that around there and swage it on and connect it. And then the float's got 4 anchor points around there. You only need to tie off to 2 diagonal points, and you don't want the anchors going vertically down. You want to have about twice the depth is the length of your rope. So if your dam's 2 metres deep, you put on at least 4 metres of rope, have your anchor points back a bit, give yourself a bit of slack. You want it tight enough so that the unit doesn't spin around in 360 degrees, because if it does that, it will wrap the cord around the motor. But you also want it loose enough so that it will go up and down according to the adjusting water levels. So what we're doing here is just tying a short section of wire rope through the corner here, because what we'll do is tie onto this rather than in the corner. We'll have a little carabiner down there so that if you want to disconnect it for whatever reason, everything's down there below water and you don't have the rope sitting up there. The aerolator control box needs to be installed by a licensed electrician, but to step you through what it does have, it's got a main isolator switch, it's got an on, off or manual operation. So inside the lid there's a timer application, and then there's a current fault light switch. When that lines up, it means something's wrong, and then there's a reset button to reset the pump again. Now, very important to mention with the control box is the control box is there to protect the motor. What it does is that it tells you there's something wrong with the motor. So if you have a light fault up here and you're not sure that it was a power related issue, or you're not really sure what it was, and then you turn it back on again and then the same thing happens either the same day or a few hours later or straight away or whatever, it's telling you that there's something wrong with the motor. So you need to get in there and pull it out and inspect it and make sure that there's no blockages or something bad going on. You don't just keep resetting this, turning on and off, on and off, on and off. From a power point of view, depending on what you're running in terms of single phase, 3-phase or solar, you need to consider what you're going to run, what power you need, and obviously you speak to your electrician about that. In this particular instance, the power is readily available right next to the dam in the shed, so I've got the electrician installing that, and we've got Daryl just digging a trench to get the cable into the water. Obviously you want to make sure that that's done all according to electrical code, whatever your electrical codes are, but just to make sure that there's no chance of any electrical cable getting damaged by grass cutting equipment or anything like that. Now, if you're in the situation where your power is not right next to the dam and it's a long way back at a house or something like that, and what you're planning on doing is running the motor from the cable from the motor in the dam and running that all the way back to the power supply, you're actually better off to do it the other way around, because what will happen is that you need to dig a 600 deep, in most cases, trench, regardless of whether you're running the power back that way or the power down this way. And the reason why you would actually bring power up to the water's edge is because when it comes time to pull the motor out, for whatever reason, in years to come for replacement or repair or whatever, it means you're not having to run the cable all the way through the underground conduit and then all the way back again when you want to reinstall it. You can easily do your electrical quick disconnect at the shore. And now for this installation, we've set the cable up and the guys are feeding the cable out as they paddle out to make sure that we get the anchor set up according to the correct cable length that we've got. And then it's just a case of, once the anchor's in place, just dropping the motor into the float. It just sits there, you don't need any special tools. And then if you've got an electrical quick disconnect, you'll connect that. If you don't have one, it's all done. Another thing that we do recommend is on the corner of the unit, running a cable tie through the electrical where the cable comes up over the float, just to make sure that if for whatever reason someone pulls on that cable, there's no tension on the wiring itself.